Well, pre-calculus classes, once again, good morning, good afternoon, or good evening. We will finish up section 4.4 now with this set of notes. One of the things I am going to tell you is that for the online notes only, I am not going to go over the warm-up and the cool-down, where in class, that's where we'll certainly do those. But what we're going to do is talk about what the graph of sine, cosine, and tangent all look like. And basically what that means is we're going to take these circular values and put them on a coordinate grid. Now, as we do that, for this first one with cosine, I am going to use a little bit more detail for this one, but then as we go and graph sine and tangent, maybe not quite as much detail on those. So we'll start at 0, and then from there, and actually we'll go ahead and we'll use radians, and then I'm going to pi over 2, then pi, 3 pi over 2, and 2 pi. Now, I am going to leave a space in between. And so we'll come back and certainly talk more about that. So these are the angles. Now, for cosine at 0, cosine is 1. At pi over 2, cosine is 0. At pi, cosine, again, because cosine uses the x values, is -1. 3 pi over 2, it's 0. And then for one full rotation or revolution, we do come back and use 1. Now, when I set up my graph, I'm going to come out here to the end for 2 pi, and then, just doesn't have to be perfect. In the middle is pi, pi over 2, and 3 pi over 2. Now, if we have a point at 0, 1, pi over 2, 0, pi -1, 3 pi over 2, and then 2 pi. Now, eventually, we'll get to the point where you'll only need these 5 critical points. For this first graph, though, we are going to add in a little more detail. And the added detail points that I'm going to use, we have 3 options. You can either use radical 3 over 2, radical 2 over 2, or a half. Well, I know which one I prefer. When I look at those 3 options, I'm picking a half. That is at pi over 3. Pi over 3, when we graph it, is closer to pi over 2. So what our graph ends up doing is it curves. If all you had were just these 5 points, basically it'd look like a V. We do use an additional point in between, at least for this first one, to show a little more curvature. Now, between pi over 2 and pi. Again, -1/2, negative radical 2 over 2, negative radical 3 over 2. Let's pick -1/2 at 2 pi over 3. Again, it is closer to pi over 2 than pi. So when I set up my graph here, I have a point there. And so again, you can see some curvature there. All right, between pi and 3 pi over 2. Again, I'm picking -1/2, which is at 4 pi over 3. And you can see 4 pi over 3 is a lot closer to 3 pi over 2 than pi. So that point's going to be about there. And then my final point between 3 pi over 2 and 2 pi, I'm going to use, again, the 1/2 at 5 pi over 3. Which is positive 1/2. And again, it is closer to 3 pi over 2 than 2 pi. So that puts us around there, and you can see we have a wave. Now, one of the other things I am going to do is show that these do, and here, let me do a little better job of showing that that does go back down. These waves are going to go on forever because you can keep going around the circle forever, both clockwise or counterclockwise. That's what those arrows represent. So, because the graph is going to keep going left and right, well, domain's negative to positive infinity. I know we introduced that somewhere along the way in one of your other sets of notes. Now, the range. Minimum y value is -1. Maximum is +1. Now, the symmetry with respect to, well, if you remember, cosine is even. Because cosine is even, it is symmetric to the y-axis, period. These graphs are periodic because you start here at the top, drops back down, you get to the top, and it's going to have the same thing happen. Well, this is one full wave from maximum to the next maximum. So the period is 2 pi. Let's start with the easy one of these, the y-intercept. 0, 1. The x-intercepts, there's a lot. Pi over 2, 3 pi over 2. Well, 1 pi over 2, 3 pi over 2. The next one's going to be 5 pi over 2, 7 pi over 2, pi over 2, -1 pi over 2, -3 pi over 2. So the x-intercepts are n pi over 2, 0, where n is an odd integer. Again, 1 pi over 2, 3 pi over 2, the next one would be 5 pi over 2. So that's what the graph of a cosine wave looks like. Next up is sine. Well, sine's going to work very similar in that we are going to use those same critical points of 0, pi over 2, pi, 3 pi over 2, and 2 pi. And for this one, we'll even go ahead and add in some of those detail points as well. All right, sine uses the y values. At 0, sine is 0. At pi over 2, sine is 1. At pi, it's 0. At 3 pi over 2, -1. And then at 2 pi, it's back to 0. So, again, 1, -1, come out here to the end, 2 pi, kind of eyeball what looks reasonably halfway, pi over 2, 3 pi over 2. So, 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and then 2 pi. Now, this one, it is going to form a wave as well. To use some in-between points now, sine our y value, I'm going to use the 30, which is pi over 6. Now again, when you add these in, pi over 6 is closer to 0. So you can see it starts there, curves up, and certainly we can even just show that it's going to keep going down there between pi over 2 and pi. Again, our best y value, 5 pi over 6. and it's still 1/2. Again, when you graph it, it's closer to pi than pi over 2. And so from there, and that's kind of lopsided, but that's also what happens when you're putting these grids on non-graphing paper. But I think you will find over time you'll actually prefer graphing sine and cosine waves without grid paper. Now, from there, between pi and 3 pi over 2, -1/2 is at 7 pi over 6, which, as you could see, it's closer to pi. And -1/2 puts us there, and so this bottom half curve isn't going to look so great. All right, last point. 11 pi over 6 is where we have the -1/2. And it is closer to 2 pi. So our wave looks something like this. Again, it does keep going. So our domain negative to positive infinity. Our range -1 to 1. Basically, these two graphs are very similar. All that's happened is you have a horizontal shift. Basically, this one has shifted, you could argue sine has shifted right by pi over 2, because instead of 0, 1, it's at pi over 2, 1. Symmetry. Well, sine is odd. Because sine is odd, its symmetry is to the origin, meaning it would have rotational symmetry 180 degrees. The period, one full wave goes from 0 to 2 pi. The y-intercept, again, let's start with the easy one, 0, 0. Your x-intercepts now are at 0 pi, 1 pi, 2 pi, would be 3 pi, 4 pi, and so on, -1 pi, -2 pi. So the x-intercepts are n pi 0, where n is an integer. So this one's actually a little easier. Now, so that's a sine wave, cosine wave. The final one is tangent. Now, tangent is different. Again, I don't know if I've mentioned this as well. When we do this set of notes, I'm also not going to worry about the cool down questions. Those are things that if we're in class, certainly we'll do those, but for just the online extra videos, I'm not going to do that. All right, tangent. Now, when we work with tangent, 0 pi over 2 pi, 3 pi over 2, 2 pi, and actually, I'm even going to come back up here and use -pi over 2. So, you'll see the reason for that here in a little bit. Now, tangent. Tangent is sine over cosine. So, at 0, y over x is 0. At pi over 2, y over x, 1 over 0 is undefined. At pi, y over x is 0. At 3 pi over 2, -1 over 0 is also undefined. And then at 2 pi, it is 0. Now, at pi, -pi over 2, again, -1 over 0 is also undefined. All right, so now what I'm going to do is come back in here to pi over 2, (3 pi over 2, and then negative pi over 2. All right, so if you have an undefined, well, what does that mean? Well, if something's undefined, it has a vertical asymptote. 0, 0, pi over 2 has an asymptote. Pi 0, 3 pi over 2 has an asymptote. And then 2 pi is back at 0. Now, as far as what is our best option for tangents in between points, well, tangent is y over x. Y over x, y over x. Well, again, we don't have any choice now other than to work with radicals, but if we take pi over 4, y over x, it's 1. So there's pi over 4, 1. Then I'm going to, between pi over 2 and pi, 3 pi over 4. Y over x is negative 1. Between pi and 3 pi over 2, 5 pi over 4. The y over the x is positive 1. Now, in between here, these form kind of like a cubic parent function shape. Now, I am going to come back and pick this one up now that you've actually seen everything in between here. Now, between 0 and negative pi over 2, we're going to use negative pi over 4, which is negative 1. And you already kind of know what this is going to look like. And then last, 3 pi over 2, 2 pi, 7 pi over 4 is negative 1. It's the same as what we had there. And we'll have a point there. Our graph is going to look like that. Now, the range. These all keep going forever, negative to positive infinity. Symmetry. Tangents odd. Yes, I know I'm skipping domain. Tangents odd, so the symmetry is the origin. Period. Negative pi over 2 to pi over 2 is now a full wave. Pi over 2 to 3 pi over 2 is a full wave. Tangent, the period is cut in half. The x-intercepts and y-intercepts. Well, the y-intercept, just 0, 0. The x-intercepts are 0 pi, pi, 2 pi. We've already seen this one. They are n pi, comma 0, where n is an integer. Now, let's come back and talk about the vertical asymptotes. There's a reason why I left domain for the end. Well, negative 1 pi over 2, pi over 2, 3 pi over 2, they are x equals n pi over 2, where n is an odd integer. I like talking about the vertical asymptotes before I come back and worry about the domain. Well, the vertical asymptotes are at x equals n pi over 2. So the domain, x cannot be n pi over 2. This is the one time where, because you have, there's no way you could really set this up well with intervals. We just let you say what n or what x can't be. So here's what the vertical asymptotes are. Again, where n is an odd integer. So that finishes up everything with our 4.4 notes on the 3 parent trig graphs.